Okay, good afternoon, faculty members, students. This will be our third lecture pertaining to the fundamentals of CNC. At the very first lecture that we had discussed, that was dedicated to the Industrial Revolution, which was considered as a preamble to the mechanization, automation, and of course the CNC. In the first lecture, we had discussed the definitions of NC, CNC, their added advantages of CNC over the NCs, and the utility of the NC-CNC system in the context of batch production, where flexibility was the key criteria. In the second class, or the second lecture of the CNC fundamentals, we had discussed about the axis nomenclature, absolute versus incremental mode of programming, classification based on the positional system, open loop, closed loop control system, and finally there was the servo system. Today we will discuss basically the repetitions of the first one, the fundamentals, but with the assistance or with the perspective of a exploded view of the NC machine tool or CNC machine tool. Although the diagram title shows it is NC, but same thing is applicable to CNC. Only thing, your input instruction in the form of punch tape is no longer required in case of CNC due to advancement in the computer technology. So content wise, components of NC CNC, part programming or part program, machine control unit, software configuration of CNC, that is a new one, and drive system, machine tool, and feedback devices. So a typical NC CNC system comprises the following elements. First of all, you need to have one part program. Okay, the basic requirement, the theme of CNC or NC machine tool, create a part program where in the form of coded instruction, where all sorts of machine tool activities, that is the tool path, auxiliary motions, other auxiliary commands like that of cool and on off, tool change, etc. Everything are coded and must be captured within the part program, so that machine tool will be, or the machining system, the machine tool itself will be capable to implement the functions, so that raw material is converted to the finished goods or finished component. So program input device, machine control unit, that is the heart or brain of the machine tool, drive system, machine tool, that is the hardware physical machine tool part, and of course the last, the feedback device. And all these we will discuss in relation to this particular exploded view. So whatever item that we had mentioned over here, you will find, you see, this is the part program number one. Since it is basically NC system elements, that is why at that time part program was prepared using a punched paper tape. So symbolically it is represented by a punched paper tape. So entire your coded instructions is captured by the punch paper tape, which is basically combinations of holes and no holes. Second, program input device. Since the coded instruction is captured or is prepared with the help of a part program, which is basically combinations of holes and no holes, so data has to be retrieved and it has to be read by a device through a input medium, so that it can be transferred to the machine control unit, and of course machine control unit will convert, which is popularly known as decoding, so that high level language or high level instructions can be converted to the machine level language, so as to interpret by the non-living system for the purpose of implementation. So here there is a program input device. To some extent it looks like your tape recorder. Okay, so in one side the tape will move, or tape needs to be forwarded, and since there are two rollers, so it will keep on rolling, and over the scanner there will be a head by which it is possible to capture the data, how it is decoded or how it is prepared in the form of hole no holes combinations. So one program input device is required. Then this is the third one, that is the most prominent, machine control unit. I will come a little bit later on, just to have a closer look to this exploded view item wise. So third is the machine control unit, and this machine control unit has got two different areas. One is called data processing unit, another is control loop unit. Next comes, I told as a part of retrofitting that in this case, in case of NC or CNC, unlike conventional machine tool, each axis motion has to be accomplished by a separate drive system. Okay, so it is basically an exploded view of a milling machine. So there is tables, this is along x axis, this is along y axis, and this is along z axis. Okay, so it is written x axis drive motor, y axis ball nut, z axis drive motor. So this particular drive motor is responsible for imparting motion along y axis. Only one is shown. So this is for drive motor along the y axis, this is for x axis. Okay, so drive system has to be there. What else are there? Typically there will be a lead screw. Okay, this lead screw has got a modification which we will discuss afterwards, that is called conventional lead screw is replaced by recirculating ball screw for improving the transmission efficiency. And finally there will be feedback devices. Okay, as the system starts on moving, the slide starts on moving, or the cutting tool starts moving, the position and the velocity should be monitored continuously by the two different feedback devices. One for position of the displacement, another for velocity of the speed. This velocity, mind that we have to relate, this velocity is a very generic mechanical term or mechanics term. But in this case, in our machine tool or metal cutting fraternity, this velocity means feet. Either you have to express in millimeter per revolution, or it can be converted to millimeter per minute, which is nothing but the unit of velocity, linear distance displacement per unit time. Okay, so now we will consider one after another. So part program is a series of coded instructions required to produce a part. Okay, so whatever informations are required or commands are necessary to convert the raw material into the finished component, everything has to be captured by the part program. It controls the tool path. So there are basically two broad categories. One is regarding the tool path, which is the most prominent of the primary. So it controls the tool path of the machine tool and the on-off control of auxiliary functions such as spindle rotation and coolant. So spindle rotation, suppose spindle needs to be rotated, or if it is a lathe category CNC, or if it is a turning center, then the job will be clamped in the chuck and the chuck will act as a spindle. Okay, so where some rotational movement has to be imparted, otherwise cutting action will not take place. So that particular rotational motion of the spindle, whether it is lathe or drilling or milling, it is immaterial, but generically it is considered as an auxiliary function. If we want to pour coolant, then coolant on off, that also comes under the auxiliary functions. Tool change command, that also comes or regarded as auxiliary function. So one category is auxiliary functions, and the primary, that is the predominantly the tool path, that is the significant portion of your commands will that comes under the purview of your entire part program. So the coded instructions are composed of alphabets, numbers and symbols and are arranged in a format of functional block. So while preparing that part program, we have to identify or we have to consider that what are the character which the system will consider. So what is the composition? The very definition of the Nccnc we have talked about, it is, as the name suggests, it is numerical control. That means control is being effected by numeric values. Okay, but strictly speaking, it is alphanumeric. That means alphabets will be there and some numerics, and of course in some cases some relational operators in the form of some symbols that will also may present in the part program, and all the instructions should appear in a logical manner in a functional blocks. If you think about, or if you want to have an analogy with our English or any Bengali or any other languages, we write a complete sentence one after another in a logical fashion, so that entire text or entire essay, whatever may be your topic or content, it must have a meaningful. Following the same logic, we prepare the entire part program, which should appear in a separate or discrete functional block and must appear following some logical sequence. Okay, so that is regarding the part program. Now come to the machine control unit. The machine control unit, as it was shown in the diagram, you see there are two different sector or different composition or different unit rather. One is data processing unit, another is control loop unit. With reference to this particular drawing will come, first is the data processing unit. Now one thing you should remember, this data processing unit and control loop unit have got their relative hierarchy. Data processing unit occupies the position at a higher level and control loop unit occupies a position in the lower level of hierarchy. To some extent, it is analogical once again or synonymous or similar to any biological system. Data processing unit takes the decision or carries out or calculations similar to our brain, and whatever decision is taken care of by our brain, in this case it is the DPU, those instructions are implemented or executed by the lower level, that is the control loop unit, similar to our manipulator like a hand. Okay, so what are the functions the DPU is supposed to carry out? First, read coded instructions and decode it. As I told in the beginning, it is written in high level language, so it has to be converted to corresponding machine language. So this conversion is called decoding. So read coded instruction and decode it so that machine can understand it and can carry out arithmetical calculation or other calculation, whatever is required in that particular format. Implement interpolation functions. At this stage I am not going to that much details of the interpolation, but still for understanding it is a very powerful task. One of the powerful tasks of the machine control unit or other DPU unit in particular. Interpolation is a very generic term. You have studied thermodynamics. I don't know whether you have used steam tables. So in the steam table, suppose some data, enthalpy, entropy, internal energy, specific volume are given with respect to a particular pressure, maybe 1 bar. Next value is maybe 1.5 bar. Now if you are interested to get those data values or the property values at 1.25 or 27 bar, how will you get it? You have to undertake interpolation. That means given the two extreme points, for 1 bar it is available, for 1.5 bar it is available, but for 1.27 bar it is not available. So you have to undertake interpolation. We go for usually linear interpolation. So what does it imply generically? Given the two extreme point properties, what will be the value for some intermediate pressure? Here also, how it is relevant? Just imagine a turning operation. In case of lathe turning operation, we have to specify in the program the coordinate of the start point and the coordinate of the end point. Now the system will have to calculate with the help of interpolation algorithm that it should follow a straight line trajectory, a straight line path. Then and then only your turning is possible. So this interpolation algorithm will help to calculate the intermediate points between the start point and the end point. So these are basically closely defined points along that desired trajectory through which or along which the tool should navigate in space. And while doing so, it will generate the appropriate geometry according to our requirement or according to the program. So this interpolation is generically or very commonly used for point to point, straight line and circular. Higher level interpolation is also possible, but usually those are not available in any general purpose or commonly used CNC machines. Those are very complicated and it requires some sort of your software. in that case we ought to express or emulate through the free form surface, which cannot be represented by common analytical functions. Okay, so B-spline, nerve surface, Bezier curves, these are some of the very popular free form surface which are used for difficult to machine areas or very complex surface which are used in aerospace industries or automotive components. So anyway, in this case mostly the interpolation that the system can execute belongs to point, straight line and circular. Even in case of circular interpolation, as a programmer, afterwards when we discuss in detail about the programming part, if you are given a task to carry out a circular path programming, then you have to give a starting point coordinate, end point coordinate and radius vector or the radius. But with the help of interpolation algorithm, system will be able to calculate all the incremental intermediate points, which in our coordinate geometry we call it as a locus of the points. So while moving from this point to this point, following a circular path, so these intermediate points you have to calculate. But in this case, we will not calculate, rather data processing unit will calculate by using that particular algorithm. So these calculations of or determination of intermediate points by along which the tool should follow or tool should move, that task is not basically interpolation. Details mathematics, numerical problems that we will discuss in the lecture number 8 or 9. Third, generate axis motion commands to the amplifier circuits for driving the axis mechanism. So in the part program, if you want to implement the cutting tool motion, you have to generate axis motion command. As I was talking about, that we would like to undertake a turning operation. So tool should take the depth of cut and will start moving from this point to this point. Okay, so this implementation will be done by the CLU unit, but this calculation part or the command part will be given by the data processing unit, since it is in the higher level of hierarchy. So the command or the dictation is given by the data processing unit. So it generates axis motion commands to the amplifier circuits for driving the axis mechanism. If you recall, or if you can go to the closed loop control circuit diagram, you will find one amplifier. Okay, the voltage which is available is not sufficient to undertake metal cutting. Okay, so that voltage needs to be amplified so as to enable metal cutting to take place, because high cutting force and torque is encountered. That is why it has to be sent through amplifier circuit. Then during execution, afterwards we will come into the CLU. So CLU will start actuating and it will measure the instantaneous position and the velocity at which it is moving. That is a part of the CLU. But the monitored values or recorded values by the CLUs by using feedback devices will be again sent back to the data processing unit for calculation of error, which will act as a further error signal to continue with that cutting process. Okay, so that is why receive feedbacks regarding positions and velocity from transducer through CLU. So this is DPU, this is CLU. It instructs command to the CLU, CLU executes, and while doing so, the feedbacks are also sent, and that DPU particularly once again receives the instantaneous position and velocity. Okay, generate auxiliary function commands such as coolant on off, spindle on off. So this is regarding, this was the third one regarding tool path, which is the primary, and regarding the auxiliary motion function, coolant on off, spindle on off, tool change if at all. So those are the things also taken care of by the data processing unit. Clear? So all intelligent or decision making functions are taken care of by the data processing unit. Now coming to the CLU. Now once execute the motion commands received from DPU. So whatever commands are issued by the data processing unit, the lower level hierarchy unit, that is CLU, will execute those commands. Okay. The feedback signals of position and speed for each drive axis is sent to data processing unit. Mind that for each drive axis, in that particular exploded view we had seen that for two different axes for milling machine, X and Y, two separate axis systems are there. So for each axis there will be separate closed loop control system, and for each axis there will be two different feedback devices or transducer, one for position measurement, another for velocity. So that is why this each axis term is important. Implement auxiliary functions such as spindle on off, coolant on off, gear change, tool change, etc. So data processing unit basically very fundamental, very easy way to remember. So decisions are taken care of by the data processing unit, and implementation part is taken care of by the control loop unit. And control loop unit also monitors, and feedbacks are again sent to the data processing unit for taking corrective actions, so that if any discrepancy is present in the system, that eventually will be eliminated completely. That is the theme. Elimination of backlash, if any, present in the screw-nut mechanism. This backlash eliminator or backlash problem should be completely eliminated to achieve the highest level of accuracy. Backlash, mechanical people know from your nut bolt or any fasteners. Due to wear and tear, there is a possibility of improper motion transfer. So if you, suppose there is a nut and bolt, so if you turn the bolt by one full rotation, it is expected that the corresponding linear displacement will be equal to the pitch or lead of the screw. But if there is some backlash, if there is some play, if there is some defect due to wear and tear, then although one complete rotation takes place, but still your other component or the attached component will not move by same amount or pitch amount or designed amount of linear displacement. It may be slightly less. So this inaccuracy is known as backlash. Now this backlash is detrimental for the performance, for achieving higher accuracy, so it needs to be eliminated. So backlash eliminator circuit, electronically it can be taken care of, but that is implemented in the control loop unit. This is another important concept. I will not say concept, rather 3 different programs. The one thing you should remember, once again, NC machines, at that time there was no computer. Okay, so there was no memory. So majority of the CPU or the machine control unit was composed of electronics hardware. Okay, this is available in our first lecture 1 PPT. Okay, but when computer came into existence in the 70s, majority of the hardwares were replaced by the softwares. So in the CNC, majority of the electronics hardware is now replaced by softwares. So that improves the flexibility, and due to availability of the computer, major advantage that can be accrued, that is programs, lot of programs can be saved, and lot of higher order functions, added features, added functions can be realized. So in that context, so which earlier was taken care of by the hardware circuits, now those majority of those hardwares are now replaced by softwares. Now 3 types of different programs are available in CNC. One is part program, which we have already discussed. This part program needs to be generated by the user. Okay, suppose you have purchased one machine tool from HMT or BFW or from anywhere. This service program and control program is inbuilt, and we as a user, according to our job, according to the geometry, we have to prepare or write our part program, and you have to execute for conversion of the raw material to the finished component. So anyway, part program as usual, I am not going to the repeating repetitions. Service program. The service program is used to check, edit and correct the part program. Suppose you are typing or you are writing the part program. By mistake, suppose in your objective is to write G in any particular command block, G01 X40 Z minus 50 F.2. Okay, some X value, some Z value with a feed value of 0.2. This is your intent side. But by mistake, suppose X or Z is repeated. Okay, instead of writing X40 Z minus 50, you have written by mistake X40 X minus 40 or 50. So the address code X comes twice in one block. So that is one your error. So the service program will guide you that there is some syntax error in your program. So that is the role of this. So to check, edit and correct the part program. Similarly, some complex level checking is also possible. There is a typical syntax that you have to follow in case of circular path generation. I told you a couple of minutes back, the start point coordinate, end point coordinate and the perfect R value or the two orthogonal components of the radius vector. Okay, under the address code I, J, K along the axis X, Y, Z. Okay, at this stage you won't be able to understand in detail what is all about I, J, K. When we will discuss about the circular programming, then you will be able to know. But the thing is that some syntax is there, some intricate calculations are there. But still, if you commit some mistake in your program writing, this service program will help you to identify that there is some error in your calculation. So this sort of checking part is taken care of by the service program. And majority of the activities which are implemented, that is taken care of by the control program. So the control program accepts the part program as input and produces signals to drive the axis of the motion. So interpretation of the compilation of your program and its execution and implementation, so that is taken care of by the control program. Okay, so in CNC, unlike NC, majority of the hardwares are now replaced by the softwares, and these three different programs are responsible to execute different functions. So this is one of the key feature of the CNC. Now coming to the machine tool area, in the first lecture, if you go to that particular slide, I had mentioned 2-3 major prominent features what is written over this particular slide. But today we will discuss a little bit more in greater depth. The slides are machined to extremely high accuracy and coated with anti-friction materials such as PTFE to reduce the stick slip phenomena. You know that friction is one of the force which is detrimental or which is a factor that adversely affect the transmission efficiency of mechanical system. So quite a good amount, significant proportion of power loss takes place due to overcoming friction. Now when a heavier component slides over any guideways, initially we require heavy force to initiate the movement. Once the movement is initiated, then quite often it happens that there is uncontrolled movement. This quite often happens with the heavy job. So sometimes there is a sticking part, sometimes followed by slipping. That is why it is called stick slip phenomena. This is due to presence of friction, which is basically due to presence of asperities into the meeting surfaces. So this is unwanted. Now how to reduce it? If the guideways are coated with a material called polytetrafluoroethylene, commercially it is called Tarkite B, a chemical compound. If it is coated over the guideways, then the possibility of stick slip motion will be rather less. So the friction will be reduced. Okay, so that is one major modifications required in case of Nccnc machine tool. This is another very significant feature. Large diameter recirculating ball screws are employed to eliminate the backlash and lost motion. Lost motion we will discuss in detail afterwards. But conventional lead screw which use Acme thread in conventional lead screws in general purpose or any other machine tools, but those are replaced by recirculating ball screw, so that your transmission efficiency will be much higher as compared to the conventional lead screw. So that again contributes to the increase in the transmission efficiency. The major contributor, the basic physics behind this for improvement in the accuracy, unlike the previous one where the nature of friction or coefficient of friction was linear coefficient of friction, but in this case it is replaced by rolling friction, and the rolling friction coefficient is much lower as compared to the coefficient of linear friction. So that is a very significant changes or modifications carried out in the machine tool level. I will come to the few diagrams. Okay, but before that, what are the other features? Rigid and heavy machine structure. Whenever turning centers or machining centers are used in the industry, the one objective is to ensure flexibility, but at the same time, to be economically viable or to be commercially viable, the productivity should be high enough. How we can boost the productivity? If you think about your metal cutting, basic fundamental metal cutting, I believe that metal removal rate you have already studied. Material removal rate is expressed in millimeter cube per minute. That means the amount of the volume of material that is being reduced or being eliminated per unit time, and that depends on the three cutting parameters: cutting velocity, feed and depth of cut. Feed and depth of cut, if you apply higher levels, it is accompanied by increase in cutting force. So there will be certain restrictions that you cannot increase the feed and depth of cut unlimited. Similarly, if you increase the cutting velocity, so force multiplied by the velocity will give you the value of power. Okay. So cutting velocity, feed, depth of cut. If you want to employ higher levels of these variables, definitely you will achieve higher level of MRR. So for that reason, cutting force will increase, power will also increase. So if the machine tool is not rigid enough so that it can withstand high vibration and cutting force, then you won't be able to employ higher level of cutting feed and depth of cut. Okay, there will be chatter mark, there may be possibility of tool breakage. So that is why machine is made very heavy and rigid so that it can withstand high cutting force vibration. Shorter machine table overhang. You know that any overhang is detrimental. From your basic knowledge of strength of materials, whenever a beam is overhang portion is there, so the possibility of deflection will be more. Okay, so if it is properly supported, then the possibility of failure or deflection will be rather less. With this concept, machine table overhang should not be higher. Otherwise, there will be possibility of deflection, which is undesirable. Another area which also helps to achieve or to boost the productivity, that is quick change tooling system. In your conventional lathe or any other machine tool, if you go for the replacement of the cutting tool, it will consume a significant portion of your idle time, which does not contribute to your productivity. So this much wastage of time in CNC can be proved havoc and will not contribute to productivity, or rather increase your cost addition. So attempt is paid so that very easily and with a quick possible time, smallest possible time, the tools or inserts can be replaced. So that is why modular tooling systems are used extensively in case of tool segment, so that tool replacement or the insert modifications is possible within shortest possible time. So this is how performance and the productivity, all these features can be addressed by taking some modifications or undertaking certain modifications in the machine tool areas. This is a view of the recirculating ball screw. You see, there is a helical groups, and through the within the groups, lot of small hardened roller bearing ball circuit. I will come for better understanding. You see this particular drawing. Okay, so this is your spindle screw. That is basically the screw. Okay, this one is the nut, this greenish color. Okay, this is actually it is wrongly shown. This arrow should be given the carriage, and this nut arrow should convert to this green color portion. So as the spindle screw keeps on rotating, so other element which is attached to it will also have a linear movement. Same screw nut mechanism, but with modification is that Acme thread lead screw is now replaced by recirculating ball screw. How it will function? As the screw keeps on rotating, if you can recall your closed loop block diagram, from the motor to the lead screw, in between there will be some reduction gear. So eventually the lead screw is imparted some rotary motion. As it keeps on rotating, the linear motion will be transmitted to the nut and hence to the carriage. So we can achieve or we can convert rotary motion to the linear motion. Now what is the speciality? These helical grooves are fitted with, see, the green color, it is a hardened steel bearing balls, and they will be in contact with each other. And thing is that there you see that there is an internal channel which is called ball return channel. How it functions? You see very carefully, two alphabets are given, A and B. Suppose just consider one ball which enters into the system at point A. Okay. Now I have shown, or in this particular diagram, there are 6 such helical grooves are shown where it is filled with the balls. Now as it keeps on rotating, these balls will keep also circulate along the helical grooves. So since 1, 2, 3 between A to B, A to this one rotation, this one to this one another rotation, this one to this one another rotation. So 3 rotation, if it undergoes, then the balls which enters at point A will occupy at position B after 3 rotation, because it follows the helical path. Okay. Now after this point, the channel is designed in such a way that it will be forced to follow this particular path and returns back to the initial starting position, thereby forming a closed path or closed loop. Okay. So that is what exactly I was talking about. Your linear coefficient of friction is now being converted to rolling friction. So that improves your transmission efficiency. So a lot of added features are there. As far as the comparison is concerned, so as a table is there, you see follow this is the first one is for ball screw. So it is inexpensive, low power use, low maintenance, high accuracy, high repeatability, high efficiency, high load carrying capacity, and of course compact in size. So it has got a significant number of potential advantages as compared to other types of mechanical systems. This is another view just for your better visualization. Same arrangement. In one side it will start moving, after following the helical grooves, it will be forced to follow the closed path. So that is how it will keep on circulating. That is why it is shown as recirculating ball screw. It is not going out. Same thing, it is following the closed path repeatedly. It is called recirculation. That is why it is called recirculation. Okay. Coming to the next point, that is the drive system, open loop control and closed loop control. In the second lecture, we had discussed in detail about the open loop, closed loop. Just few highlights. In the open loop control system, stepper motor is used and not suitable for precise movement, because when it encounters heavy load, okay, so there may be possibility of losing the steps. That is why for all commercial purpose, stepper motors are not used or not recommended. Only for lighter jobs where high precision is not required, in that case you can use, because it is inexpensive. A pulse generator is used to generate rectangular pulses that drives stepper motor. Okay, regarding pulse generator and regarding issuance of pulses, its calculation part we'll discuss afterward with the in relation to the analysis. In contrast, in the closed loop control system, DC servo motor or AC servo motor is used. The servo means sense and act. So this feedback devices is coupled or will act in synchronization with the motor. So depending on the feedback values, the servo motor will keep on rotating by the precise angular amount. So precise displacement, angular displacement is possible to attain by using servo motor, and that is why it is recommended in case of CNC system. In the earlier times, initially it was started with the DC servo motor, but afterwards these DC servo motors are increasingly being replaced by AC servo motor because of some potential advantage. First of all, very low maintenance required, quick response and low power to weight ratio. Afterwards we will discuss each and every topic in detail. Finally, feedback devices. As I told, that one is position or displacement measurement and another is the velocity measurement. So for positional measurement, either you can use linear scale, which is based on some physics principle. It is called Moir fringe pattern. It is some sort of interference of light, principle of interference of light. Okay. So again, we will have a separate lecture exclusively on the feedback devices. And another popular one is rotary encoder. It is a disc type of item which is mounted at the end of the lead screw. So as the lead screw starts rotating, this encoder disc also will start rotating. Now on the encoder disc, there will be some alternative transparent and opaque region. So if one side there is photocell and if on the other side there is a light source, so light will pass to the transparent portion and the corresponding photocells will be energized and pulses will be emitted. Those series of pulses, eventually it is in the form of sinusoidal pulse, because its intensity keeps on increasing to the maximum, come to the nominal level, then minimum, then again rises. So it will form sinusoidal curve. Eventually there is a typical circuit called schematic trigger circuit, by which it can be converted to the digital or the square pulse. In the digital form is 0 and 1. Okay. So that is utilized for position measurement, and for velocity feedback, the tacho generator is the most appropriate one. So that covers the your entire different components of the okay. So what we have discussed so far from the very beginning: Nccnc definition, characteristics, features, how it can be advantageous over conventional or earlier mass productive machines to offer mostly the flexibility and to make it amenable for the current batch production or mass customization business philosophy. What are the major components? What are the basic principles? What are the components and the function of the CLU, DPU, and together if we consider, that is the machine control unit, and what are the modifications are required in the machine tool or the machine tool side, so that in the mechanical side also we ought to change certain or to undertake certain modifications, so that our transmission efficiency, accuracy, repeatability will improve. Okay, so that is the introductory part. Next class onwards we will discuss about the some analytical calculation, number of pulses, precision part, pulse frequency, encoder gain, which will help us to go for the design analysis of the Nccnc systems. Okay, thank you sir for your help and support, and thank you students for your patience hearing.